Hi everybody, welcome to CompuScholar's Professional Development webinar for February of 2023. This is the time of the year where you start thinking ahead a little bit to the upcoming school year and start trying to plan your strategy around the courses that you're going to be offering. So today we thought we'd talk about popular high school programming languages and best practices in designing course tracks to appeal to your high school students. We'll begin by reviewing the industry demand for specific programming languages, what's popular and what's not. And then we'll talk about some of the goals of your high school program, especially within the CTE department. And finally, we'll talk about designing that four-year course track for your CTE department and your high school students. We'll talk about some traps to avoid and how to best support the ideal goals of your CTE students. So to begin, let's talk about the industry demand for programming languages. And what we've listed here is what we're calling the most popular programming languages way back in 2018, which is about 5 years ago. And we'll start by saying that the methodology differs. So you can Google the most popular languages and you will get a number of different articles that rank them differently, and everybody has their own methodology. So the big takeaway from this slide is that you see that there's different languages ranked differently by different sources. And so it's really hard to pin down what is the most popular or the most useful programming language. A lot of it's going to depend on your context. Let's fast forward those 5 years. It's now 2023. So we did a new survey, looked at a bunch of different articles again, and picked a couple of likely sources. And again, you can see that the sources, even in 2023, don't really agree with each other on what's the most popular programming language. And you can see that the general purpose programming languages like Java and Python and C++ and C# and so forth are still pretty popular and well represented. However, some new languages have crept in over time. And so the takeaway from this is that in the 5-year period since we last did the survey, new languages have appeared, and by the time the student graduates from high school and goes into college and completes a college program, new languages again would appear. And so when we're thinking about languages to teach our high school students, it's really difficult to project ahead to what they might need 3, 4, or 5 years down the line. So of course the big question that we're asked quite frequently from parents and from administrators and teachers is, what language should my high school student learn to make sure they have the best chance of success in the job market? And our answer is pretty consistent in that it does not matter at all. And so that might be surprising to some of you, but it is our belief that it's not the language that you teach, but it's how you teach it. And let's dive into this a little bit more. So for a software engineering job, an employer generally is going to be looking at a 4-year degree. So we're not trying to graduate kids from high school directly into the job market. Employers are not going to look at their high school experience, so they don't care if you've learned Java versus C# versus Python in high school. The nature of the languages that they're looking for might change over time, and being multilingual is important. So employers today would highly value an employee that knows multiple languages, so it's important to be somewhat fluent in many languages and not just focus on one. So while you're in college and you're starting to think about that first internship or your first job after you graduate from college, what will help you out in that interview? Certainly your grades and what you're studying while in college will be a hot topic of conversation. Again, they're not going to drill back into your high school experience, but they're going to focus on what you're doing in college. If you've been in college long enough to take an internship, they'll definitely focus on what you did last summer in that internship. And the interviewers are looking at your ability to communicate and answer questions. And of course, references and connections to get yourself into a company are always super important as well. So none of this has anything to do with what you've done in high school or the particular language that you selected as your introductory programming experience while you're in high school. In many states and districts, a computer science course is under the umbrella of a CTE organization or the CTE department. And as you know, CTE administrators and teachers are very job focused, so they're trying to prepare students for the job market, maybe churn out some mini Java engineers or some mini Python engineers by the time they've graduated from high school. They'll spend a lot of time on things like software process and getting certifications and talking about soft skills like customer support and that sort of thing. And we would respectfully suggest that these goals are missing the mark And certainly on behalf of all teenagers everywhere, we would say boring, right? That's not necessarily what students want to do when they get into a coding class. So when we get a chance, we always recommend to a CTE department that for computer science, your goal isn't necessarily to prep somebody for the job market, but it's to get those students interested in computer science and pursuing that as a possible degree in college. And so that's a little bit different than the goals of a normal CTE department. We recognize that, but in terms of what is the best interest of the students, again, we want to get students into college, get them interested in computer science, and the way you would do that is offering a variety of introductory courses. You're just looking for those 1 or 2 courses that really grab a student's interest and make them say, hey, this is really fun. This is something I would love to do. So they don't need 3, 4, or 5 years worth of experience in computer science to make that decision. They just need a good introductory course in any programming language. It's also important that students be able to schedule these courses at any time. So flexibility is important. We would hate to have a rising high school senior wake up and say, hey, I'd like to try computer science, but because they didn't get into their CTE pathway back in 9th grade, they don't have that option any longer. So we'd love for students at any age to give it a try and see if they like computer science and make that decision to pursue it in college. So in many states and districts, we've seen what we call the pyramid trap when it comes to setting up your 4-year courses. In many cases, a state or a district will start off with computer programming 1 as a baseline and then move a student into computer programming 2 and 3 and some sort of practicum in your senior year. And so you've got this kind of pyramid pipeline. And the reason we've drawn it as a pyramid is that in the first year, you usually start out with quite a few students. There's a lot of students that are interested in computer programming. They want to give it a try. But by the time you reach that 4th year, your students have dwindled down to very few. It's hard to get kids all the way through that pipeline. It's hard to find teachers with enough experience to teach those advanced coding concepts. And it's hard to find curriculum. Publishers like CompuScholar recognize there are very few students up at the top of the pyramid, and so we're not producing curriculum for that little niche. And as an interesting data point here, you can see in the state of Texas, which has well-defined course tracks and good numbers on their students. In Texas, what they call Computer Science 1, they'll expect about 25,000 students per year to take that course. And Computer Science 2, it drops to 5,000 students. So you can see there's hard evidence of losing about 80% of your students as you move from Computer Programming 1 to Computer Programming 2. So if we want to avoid the pyramid trap, what would be an alternate way to set up our courses? And again, let's keep in mind our goals. We want students to be able to take these courses at any time from any grade level. We want them to be fun and interesting to the students. And you want to have curriculum that covers these topics, and you want to have teachers that are able to teach the topics. So with that in mind, we simply suggest offering your students a wide variety of things. You can start them off in digital literacy or any programming language that catches your fancy. You can offer them video game design, web design. They can go into one of the AP computer science courses if they would like, either principles or CSA. And there's really no major prerequisites between these. So if a student wants to leap into web design or AP CSA or anything else that catches their interest, they should be able to do that from any point in time. And the great thing is that all of these courses would be popular. You'd have plenty of kids for each one of these courses. You'd have curriculum for these courses, and you'd have teachers that are able to teach them. Now, certainly we realize that designing and changing course tracks is a long-term process, and many of you have very specific requirements at the state or district level. So the state will define computer science courses for you. They may design prerequisites between the courses, and there's very little control that you have over that as an individual teacher. However, when you're trying to turn a big organization and move it in a new direction, the key is applying some pressure early and consistently. So that means if you have an opportunity to speak up, we would encourage you to do so. If you're on state panels for reviewing curriculum or designing course tracks or setting standards, those types of state panels are always happy to get your feedback. And they're looking for some volunteers with vision to help set the state's course in the future. Secondarily, what we've seen is that teacher availability and training is important. As you know, there's a shortage of trained computer science teachers in many states and districts, And so often a school or a district's computer science program will rise and fall with a single teacher. So if the teacher that does that in your district leaves, sometimes the program has to start over from scratch. There's not a lot of institutional memory there. And so one good way to help combat that is having some sort of external partner like CompuScholar, where we've got curriculum for all 4 years of high school plus some things in middle school. And we do a lot of teacher development and so forth. So we'd love to help you out. We'd love to present this kind of information to your district or your state stakeholders if they're interested in talking more about course tracks and programming languages. Our door is always open. So I hope this brief webinar gives you a little bit of food for thought as you move forward into designing your course tracks and selecting your programming languages for your high school students. As always, we appreciate your time, and you're welcome to contact us with questions or comments. You can give us a call or shoot us a message through our website. Thanks for watching.